Okay, so in this video we will discuss about Arduino and how to program Arduino. So this is about introduction to Arduino. So in this video we will discuss about microcontrollers, and then we will discuss about the differences between the microcontrollers and Arduino, and in that we will discuss about Arduino hardware. Then we will discuss about microcontroller programming. Thereafter, we will discuss about Arduino programming, and at the end of this video, we will go through some Arduino examples. So these are the objectives and learning outcomes. So students should be able to understand the importance of microcontrollers, and they should be able to use these microcontrollers in appropriate situations by selecting appropriate microcontrollers. So in this video, I will give you a brief explanation about microcontrollers and the importance of microcontrollers. So then, as I introduce you to the Arduino, students should be able to understand about the importance of Arduino and use this Arduino in simple applications. So students should be able to understand about the Arduino hardware and how to program Arduino. Then also they should be able to perform simple tasks using Arduino. So these are the objectives and learning outcomes of this session. Okay, so first we will discuss what is a microcontroller. A microcontroller, or sometimes it's also called an embedded controller or microcontroller units, MCUs. So a microcontroller is a compact integrated circuit IC designed to perform specific operations in an embedded system. A microcontroller includes typically a processor, memory, and input-output peripherals on a single chip. Okay. So a microcontroller is a compact IC designed to perform specific operations in an embedded system. So here we need to discuss what is an embedded system. So basically, embedded system is a computer system which is a combination of a computer processor, memory, and input-output devices. And this system is used to some dedicated functions within some mechanical or electrical system. We have many applications, many examples for these embedded systems. For example, we can say some robotic applications like line following robots and robot hands. And we have now developed, humans have developed navigation systems like auto driving cars, like that. We have many embedded systems. So these can be some complex systems or some simple systems. So in this picture, I have shown a microcontroller, and these are some of the input or output peripherals. These can be connected to the microcontroller and used to develop an embedded system. So for example, we can say having a button or keypad as the input to the microcontroller and display the state of the keypad or the button in a LCD display. So that is also a simple system, embedded system. So using that and developing such a system, we can have an example like keypad control door lock system. Like that, we can have embedded systems. So microcontroller is a IC. Here is an example which is designed to perform specific operations in an embedded system. Embedded systems are constructed using different input and output devices in combination with the processing and the memory using these microcontrollers. So a microcontroller includes typically processor, memory, and input-output peripherals on a single chip. Okay. So if we consider about this as the example, then in this chip there is a processor and memory segments, and these pins, some of these pins will be used, will be able to use as input and output in this microcontroller. So when we are discussing about microcontrollers, we can divide microcontrollers depending on their hardware. So mainly we can divide microcontrollers depending on how many bits are operating in a microcontroller or memory devices, whether the memory is embedded or we can connect the memory external, or depending on the instruction set, whether it is a complicated instruction set or reduced instruction set. Also, we can divide microcontrollers depending on memory architectures like Princeton and hardware. So another important thing I want to emphasize in here is we are having different types of families for microcontrollers. So depending upon the manufacturer, they have developed many microcontrollers. So we have several microcontroller families. This PIC and ARM and at Mega, like that, we are having many microcontroller families. Then you can see in here, we can divide microcontrollers into many parts. So depending upon that, we have to choose appropriate microcontroller for our application. So when we are considering to select a microcontroller, we have to consider several things. First, one of these things is number of input and output pins that are in a microcontroller. So if you are planning an application with many input and output devices integrated to the system, then we have to select a microcontroller that has many input output pins. Also, we have to consider clock frequency of the microcontroller. So if you want to operate very fast operation, for example, sample a very high frequency signal, then we need to select a high frequency microcontroller. Also, we have to consider about the storage memory, and there are several things to consider when we are selecting microcontroller for an application. So depending upon the hardware structure, and depending upon hardware structure, there are several microcontroller families, and they are varying from one manufacturer to another. So we can select these microcontrollers according to our consideration to develop an embedded system. So we can connect these input and output peripherals to a microcontroller and develop the embedded system. So when we are considering about some of these examples, let's consider about the microcontroller that we have in our Arduino Nano board. So it is that IC is at Mega 328P. Okay. So if you go through the datasheet of a microcontroller, you can see all the details, all the important details are mentioned in this datasheet. So you just have to Google that specific microcontroller by its name. So here I have searched for at Mega 328 IC. Okay. So if we go through this dataset, so it is mentioning the hardware structure and all the important features in this microcontrollers. So we have several microcontroller packages depending upon the external appearance. We can divide these microcontrollers into several packages. So we have TQFT package and PDIP dual inline package. Like that, we have several packages. And in this datasheet, all the important things about these microcontrollers are specified. Here, each pin are specified. What are the features of these pins and how to use these pins are given in this data sheet. So if you want to select a microcontroller for a specific task, one thing you can do is going through the data sheet and see whether you can use that microcontroller for the wanted task. Okay. So then we have Arduino. So what is the difference between Arduino and a microcontroller? Arduino is an open source hardware and software company which develops Arduino boards, and these Arduino boards are microcontroller unit boards which consist microcontroller as a part of it along with the USB ports, general purpose input output pins, and many other hardware. Okay. So we discussed what is a microcontroller. Microcontroller is just the IC. So then these Arduino boards have been developed. In that, this microcontroller is integrated, and there are other hardware components in this to simplify our use. Okay. So if we consider about the microcontroller, we need to program this microcontroller according to our task. So in this Arduino board, that Arduino does not need a separate piece of program, separate hardware component programmer to load new programs to the microcontroller. So it is integrated in the Arduino board. We can simply connect this Arduino board to a computer using a USB connection, and we can program the microcontroller. Okay. So that is a very important feature of the microcontroller. So we can program this microcontroller according to our specification and use it for different tasks at different times. Okay. So in an Arduino board, there are many other hardware components such as power cord. We can power this Arduino board using a jack, power jack power supply connected to this power cord, and to voltage regulate. There's a voltage regulator, and there are crystal oscillators and reset switch and indicators for serial communication, RX-TX indicators, and there are digital pins and analog input pins. Like that, not only the microcontroller, there are several other hardware components integrated in this Arduino board. Therefore, we can easily use these Arduino boards to develop embedded systems, because most of the important hardware components are attached to this Arduino board. Therefore, without further working on for connections like program, how to have the programming hardware and voltage, external power supply, those are integrated in this. So therefore, we don't need to spend time to add those features to microcontroller, and those are integrated in this Arduino board. Therefore, we can just upload the program and connect our input and output configuration and power those input and output peripherals. We can use this Arduino board. Okay. So that is the difference between the microcontroller and Arduino boards, and the importance of Arduino boards. So now let's discuss. So I mentioned that we can program this microcontroller for our different tasks. For example, we can use microcontroller at a specific time to display a LED pattern by programming the microcontroller, and we can change the program and change the LED patterns. Okay, like that. So if you want to so let's say we want to integrate the keypad to this microcontroller, then we can write another program and load it into the microcontroller and use that. Like that, we can change the code in the microcontroller and use that microcontroller for specific tasks. So how to program a microcontroller? For that, we can use programming languages like C, C++, and Python. So if we are writing a code using this type of programming language like C, then we need to compile that program into machine language. So we can compile it directly into machine language, or we can first compile it to assembly language and then assemble it to machine language. So in order to understand this code by our microcontroller, that program has to be in machine language. So we have to compile the program and upload it to the microcontroller to understand and perform tasks using microcontroller. So when we are discussing about Arduino has its own platform to program. So we call it Arduino IDE, Integrated Development Environment. So this Arduino Integrated Development Environment has a simplified, so it uses a simplified version of C++, and so it is easy to learn and program using this Arduino IDE. So when we are working with Arduino IDE, it has the code editor, and it is doing this compiling process. Also, it has a debugger. Okay, so debugger means if there are some errors in the code, then this Arduino IDE it will indicate those errors. Okay. So that is how to program an Arduino board. Also, Arduino board can be programmed. So there is a basically microcontroller. Therefore, it can be programmed using these mentioned languages as well. But most of the time we are using Arduino language and Arduino IDE because it is easy and there are many libraries developed. This Arduino IDE is open source package, and because of that there are many libraries developed for this Arduino. So it is easy and simple to use Arduino IDE. Okay, so if you go through this Arduino website, you can find details about this Arduino boards. And also you can download the Arduino IDE software. So we are having different types of Arduino boards. So these are entry-level Arduino boards. We are having Arduino Uno, Arduino Nano, Arduino Leonardo, Arduino 101, Arduino Micro, and Arduino Nano. Every like that, we are having different types of Arduino boards. And depending upon these Arduino boards, the size is varying and number of input-output pins are varying. Also, there are several other specification variation depending upon these boards. If you consider about this Arduino Uno board, so it is having a microcontroller at Mega 3280. Operating voltage is 5 volts and input recommended voltage is 7 to 12 volts. And input voltage limit is 6 to 20. There are digital input pins 14 digital input and output pins like that. Those specifications are given in this website. Okay. And let's consider about Arduino Nano. So this is the appearance of Arduino Nano. So it is having a Atmega 328 IC. Packaging is different from the previous Arduino Uno, and it is having analog input pins, 8 input pins, and digital 22 digital input and output pins, like that. Specifications are given in this website. We have this is the physical appearance, and details are given in this way. So design of digital input output pins 20 digital input output pins, and 7 PWM channels and 12 analog input channels. So also there are some other Arduino boards with enhanced features. You can go through those in this website, and these are using for Internet of Things. Like that, there are many Arduino products. These are considered as retired versions. Then there are many Arduino products that are available. So if you want to download the software, you can download it from this site. Just go to Arduino website and software downloads. Then in that you can download the Arduino IDE. So it is available for Mac, Windows, and Linux. All the versions this Arduino IDE is available. Okay. So you can download it using this Arduino website. Okay, so now I have downloaded Arduino IDE and install it and open the example available in this Arduino IDE. You can access examples available in here, file, examples, and you have many examples available here. So I have opened basic example of blinking LED using Arduino. So if we consider about this Scratch, so Scratch is the name that Arduino uses for a program. It's the unit of code that is uploaded to and run on the Arduino board. So when we are considering about this Scratch, first we have some comments. So you can either have multi-line comments or single-line comments. Multi-line comments are starting with slash star and ends with star slash. And you can have single-line comments like this, and it starts with 2 slashes. So when you run the Arduino Scratch, when you compile Arduino Scratch, these things inside these comments will be ignored by the Arduino. Okay, so comments are ignored by the Arduino. Then we have variables, for example here, and a variable is a place for storing a piece of data, and a variable has a type. Consider about here, its type is int, and name is LED, and the value is 13 given for this variable. Okay, so this is a variable, and how to define it. So this is the initialization of a variable. Then we have functions. This is example function. Void return type is void. and the name is setup. And if we are having some inputs for the function, then we can indicate inside these brackets. And the body of the function is inside two curly brackets. And we can call functions like this. For example, this pin mode line LED output calls the pin mode function, and it is passing two parameters to that pin mode function. Two parameters are LED and output. So we assigned 13 for this LED variable, and whenever this LED variable is called, number 13 is retrieved for that position. So it's a passing value pin mode 13 and output. Okay, and so we can use functions like that. So we have several functions here, several inbuilt functions: pin mode, digital write, delay, like that. So we discussed that pin mode function configures a pin as either an input or output. To use it, you need to pass a number to the pin to configure and constant input or output. Thereafter, when it is configured as a, if you consider it as an input, the pin can detect the state of a sensor like a push button. And if we set this pin mode as an output, then you can drive actuator like LED. Okay. Then we have digital write function. So it is passing the LED, is calling LED, and the value number 13 will be passed to this function and the state. So if we set this digital write to high, then the pin 13 will set to high, which is 5 volts, and writing it to low will connect it to ground 0 volts. And the delay function causes Arduino to wait for a specified number of milliseconds. So if we consider about this line of code, so it is waiting for 1000 milliseconds. Okay. This setup function and loop function are important. This setup function and loop function are two important functions in Arduino code. This setup function is called when the sketch is started, and it's the place where we normally specifies the tasks like pin mode and initialization of libraries. And this loop function is called over and over again, and when the code is running, and it's like the heart of the sketches. So those are the things about this Arduino sketch. You can add libraries and add more functions and do many tasks using this Arduino sketch. And for that, you need to upload the Arduino sketch to the Arduino board. For that, first you need to select the type of Arduino board that you are using. For that, go to Tools and Arduino board. There are, I call the approximately all the Arduino boards available. So we are using Arduino Nano in this situation. Arduino Nano. Then sometimes there are several processors for Arduino Nano boards. Then you need to select the processor. Also, you need to select the connected port to the how the Arduino board is connected to the computer. So what is the port that you are using for the Arduino connection. You need to select that. Then you can verify the Arduino code. So I mentioned that Arduino IDE can be used to write the code and to compile and to debug. So once you compile, it will indicate it is compiled, done compiling, and if there are any errors, it will indicate in this section. Then you can upload it to the Arduino board by pressing this icon, and it will indicate uploading and done upload. Okay. So once it is uploaded, you can see the inbuilt LED is blinking in the Arduino Nano board. Okay. So that is our first example, blinking the inbuilt LED in the Arduino Nano board. Okay, so now I have edited this stretch to display a LED pattern. For that, I connected several LEDs to the Arduino board. So in this example, I have connected 5 LEDs from pin number 2 to 6 in the Arduino Nano board. So first, I have to initialize these pins as outputs. For that, I have used a for loop for I equals 2 to I less than 7. So it is going from 2 to 6, I plus plus. All these pins are set as outputs. Then I have write a simple code to turn each of LEDs one by one and turn it off sequentially. So if you consider about this for loop, so it is starting from I equals 2, and first it will turn LED connected to pin number 2 on, and it will wait for 100 milliseconds, then it will turn off. Then this I will be incremented by 1, I plus plus, I will be incremented by 1, therefore I is 3, then LED connected to pin number 3 will be turned on for 100 milliseconds, then it will turn off like that. This LED pattern will go from right to left once this code is uploaded to Arduino Nano board. So you can see the LED pattern once this code is uploaded to Arduino Nano board. So in here, the LED pattern is going from right to left, and if you want to display it from left to right again, you can have another for loop. Now it has to go from sixth LED to sixth pin to second pin. So once it is uploaded, you can see it's going from left to right. So like that, we can easily display LED patterns by changing the code and uploading it to the Arduino board, and we can have several methods to display several simple to complex LED patterns using this Arduino coding. So in here, to display a simple LED pattern, I have used for loops and connected several LEDs to the Arduino Nano board. Okay, so that is our second example, how to display a LED pattern using Arduino. Okay, so now uh, let's discuss about how to read a digital pin and to communicate in between the Arduino and the computer. So we discussed about digital write, and now let's discuss about digital read. That is how to read the digital pin. So it is reading whether it's in the high state or low state. So for that, first we need to initialize the pin. So in this situation, pin number 2 as an input. Then we can read the state of that pin, whether it is high or low. Also, we can communicate in between the Arduino and the computer using serial communication. So in the setup, I have to initialize the baud rate of the communication, serial communication. This baud rate we have set as 9600. It should be the same in the Arduino and the computer in the reading and writing uh, components. So this when if these baud rates are not set to be equal in the both of the devices, then the data will be scrambled and we will not be able to communicate between the two devices uh, appropriately. So in order to communicate between two devices appropriately, this baud rate have to be equal in the both of the devices. So then I have initialized two pins, one as input and one as output. And so when we go to the loop function, first I have set the digital write 3 low. So I'm setting the pin number 3 as low. And then I'm reading the digital read the state of the pin number 2 and assigning it to the variable state 1. Then I'm serial passing that state to the computer and wait for 1000 milliseconds. Okay, so if I run this code and in the circuit I have connected pin number 2 and 3 together, so then I can read the state of pin number 3 by pin number 2. Also I have connected the LED to the pin number 3 and the ground to indicate the state of the pin number 3. So once I upload this code and I can monitor the serial sending value using serial monitor or serial plotter if it is a number. So I will use serial monitor in this situation. So it is sending 0 consecutively because that is what it's reading from the pin number 2 and sending to the computer. Okay. So important thing is I have set the same baud rate in the computer as the Arduino. Now let's set the state of the pin number 3 to high. So this pin number 3 is set to high, then pin number 2 will read the pin number 3 as high, and that value is passed to the computer using serial communication. So we will be able to observe consecutive number 1 in the serial monitor. Okay, so we can see it's sending number 1 consecutively to the computer. Now let's toggle the state of the pin number 3. So let's assign a global variable int I equals 0. Then we will toggle the state of that int. Toggle the state of the variable I. I is changing whenever it's coming to this point. So if it is 0, then it will become 1. If it is 1, then it will become 0. And let's assign value to the digital byte. So we can see when the LED is turning on, it is indicating 1, and it is turning off, it is indicating 0. So it is passing. We are reading the state of the LED, state of the pin number 3 using pin number 2, digital read 2. We are reading the state of the pin number 3 using pin number 2 and sending it the value using serial communication. Okay, so that is our third example. Okay, now let's discuss about how to read the analog value using audio. So I have wrote a simple code to read the analog pin and pass the value to the computer using serial communication. So in the setup, we don't need to specify we need to say we. So in the setup, we don't need to say whether the which pin is using as an analog in or analog out. So in the setup, it's only initializing the serial communication, and in the loop, we are reading the analog pin A0, and so it is assigned the value VAL, and we are passing that value PAL through the serial communication to the computer, and we can monitor that value using serial plotter. So in here we can see the variation uh, of the analog read. So when we are reading analog value, it reads the value from the specified analog pin, and Arduino boards containing multi-channel 10-bit analog digital converter. It means that it will map the input voltage between 0 and the operating voltage, for example 5 volt, 3.3 volt, and it will turn into integer value between 0 and 1023. Okay, so that's why we are observing a value around 936 in this situation, where I have connected A0 pin and V in input. Okay, then we can observe a value nearly 936. So when I connect the A0 and the ground, then it is indicating 0. Likewise, we can observe, we can monitor analog values using Arduino, and because it is a 10 bit channel, 10-bit channel ADC converter, it will indicate the value in between 0 to 1023, and we need to convert that value appropriately in order to if you want to measure the voltage, analog voltage in each situation. So when we are providing 5 volts, it's indicating 1023. And when we go is specifying around 727. Like that, we can monitor, we can read analog values using Arduino, and because it is 10 bit ADC, it will indicate 0,1023. And if you want to measure the voltage, then we need to convert that appropriately. Okay, now, so next example, let's discuss about analog write. So we discussed about analog read, how to read analog value using Arduino, and now let's write analog value into a pin using Arduino. So for that, first I have assigned a variable LED pin number 3. Then, as we discussed earlier, we don't need to specify anything inside the setup function for analog read or write. And then inside the loop function, we are assigning analog value in between 0 and 255 to the specified pin that we want to assign the analog value. So when we are writing an analog value using this analog write function, this writes an analog value PWM wave to the pin. PWM stands for pulse width modulation. So it's turning on and off according to our analog value, and we can observe the analog value at the output. So if you want to uh, output the 2.5 at a specific time, then if the full reference is 5, then with 50% duty cycle PWM wave, we can obtain 2.5 volts. Like that, we are using pulse width modulation to obtain an analog write, analog output at the specified pin. So analog write writes an analog value PWM wave to the pin, and we can connect a LED and observe the variation of brightness because of the variation of voltage. Or also this analog write PWM wave is using to drive a motor at various speeds. So after a call to the analog write, the pin will be generating a steady rectangular wave of the specified duty cycle until the next analog write or the digital write or digital read comes to the same pin. Okay. So when we are using the analog write function, first we need to specify the pin that we are using to output the analog value, and then we are specifying the duty cycle. So when we are specifying the duty cycle, if it is 0, then it's always off, and if it is 255, it's always on. And like that, we can specify the analog PWM duty cycle. PWM, by specifying the PWM duty cycle, we can give a analog value to the each of those analog pins. So in here I have specified duty cycle as 0, duty cycle feed analog write value as 0, so its LED is off. And if we change it to 155, we will be able to observe the LED in full brightness. And we can change this value in between 0 and 255 like 100 and observe the change of variation of the brightness of the LED. Okay, like that we can use analog write function in Arduino codes. So another thing we can do is we can observe the fading in the LED using the available example. So in this example, it is using the analog write function to change the voltage provided to the LED using PWM signals, using pulse width modulation. So each of the step, it is first it is increasing the fade value by 5 points, and then it will decrease the fade value by 5 points. So when we once we upload this code to the Arduino, we can observe that LED is fading. Okay. Like that, you can see the change of brightness in the LED. So for this session, we discussed about the importance of microcontrollers, and then we discussed about the importance of Arduino, and then we go through the hardware of the Arduino and hardware of the microcontrollers. Then we discussed how to program microcontroller, how to program Arduino using Arduino IDE. Also, we go through several example tasks, starting from digital write, digital read, and serial communication, analog read, and analog write. So these are very simple examples. We can do many more tasks using Arduino. So this is as an introduction to Arduino. We discussed about those tasks. You can go through many examples and work out many uh, solutions for available problems using this Arduino, and you can do many things using Arduino. Okay, so thank you.